Hey everybody, my name is Andy Ballester, and I'm the Chief Product Officer of EyePop.ai. Today we're going to be learning about deploying AI to the edge. In today's workshop, we're going to be deploying the EyePop.ai runtime to Windows X Elite with a Snapdragon NPU, and we're going to be optimizing our models using the Qualcomm AI Hub. And so my device looks like this. We will be demonstrating today how to detect people and their pose, along with a custom model that will be deployed to the edge that detects eyeglasses. So let's dive in. This is the EyePop dashboard. If you'd like to learn more about our default AI vision pipelines or cloud deployment, I'll paste a link to our quick start guide below. In the example we're going to be looking at today, it can be found in our developer documentation. And so we're going to click on Dev Docs, and we are going to look at how to train a model. And in how to train a model is deployment, and we're going to deploy to Windows Runtime. The first step to deploying AI to the edge with EyePop is to download our current runtime. We have a link in our developer documentation here. This is designed for Windows machines using the Snapdragon X Elite processor. When we download that, we can run that setup that will install the current runtime to your system. And we can look, and we have a setup link to our dashboard. This is the developer preview. This can also be servicified or packaged into your Windows application. And so we're going to be using this as the developer preview right now. When I start this the first time, it's going to ask you for your API key. Follow our quick start guide. It's really easy to get your API key from the dashboard. And so you're going to go ahead and cut and paste your EyePop.ai API key into this window here. That will configure your system to run against your API key. And that is what's going to allow this system to authenticate with our model library to download models and cache them at the edge. Once those models are onto your system, they no longer need to talk to the outside worlds. Then this device can be cut off from the internet and perform inference. So go ahead and do that now. The next step after setting up your Windows runtime is to set up your development environment so that we can run inference locally. The first thing we're going to be doing is running this in Python, and then I will show a React example after that. And so let's go into my Visual Studio. The code that we'll be running today, the first version, looks like this, very similar to the example on our dashboard. Uh, we have an SDK that makes running Python examples very easy. And so we're going to be using that SDK today. And so the first thing we need to do is import our SDK. We're going to be importing some types, and this is for composing our POP. A POP, if you haven't checked out the Quick Start Guide, is a computer vision recipe and an AI worker server put behind an endpoint that you can talk to through normal web API calls. And the next thing we'll do is we'll import example pops. These are configurations of models working together. And so we're going to see a couple examples today. The first simplest version is to just detect people in a scene. And so we'll take a look at what that looks like from configuring your pop. Our file path, we could do something a lot fancier. We could stream in the webcam. We could make a file picker. We could make this into an argument to pull files in from our folder structure. Right now, we're just pointing it directly to a file. I've prepared a number of example people images here so that we can take a look there and use those for our examples today. The next thing we need to do is instantiate our worker endpoint. On the edge, this ends up being actually easier than when we configure this for the cloud. We don't need to give the worker endpoint any configuration. All of that configuration has already been done by pasting in your API key into your local runtime. And so we're going to use that as endpoint. The first thing we need to do to configure the endpoint is to set our POP. And so let's take a look at what that is doing. And so the first thing that we want to do is find any people in the scene and draw a box around them. And so we have this person pop. We create a pop component. We are going to be doing inference today, and we're going to be using the EyePop person latest. That's one of our models that comes with your EyePop account. And so very simple inference. We're just using one model, and the runtime will take care of deploying that to your local machine, and um, our code will do inference on that particular model pipeline. All right, and the next thing we do is we're going to upload our example image, and we're going to use predict to give us results. And all we're going to do in this simple example is just dump the results to the screen. And so let's take a look at what that looks like. Okay, and there we go. What that did was that pasted in our first image, which is this person here. We sent that to our local device. It responded with our standard EyePop structured JSON and gave us the objects that it found. Now in this pipeline, we configured it just to look for people. And so it found one person in there with high confidence. It gives us the bounding box that describes that person. It also gives us a little bit of information about the current image that it looked at. Now, we could do a lot more fun things here. And so JSON, while this might be good for an integration into my product, for today, we want to actually visualize what it found. And so I'm going to dive into our second example here. We're going to be doing a lot of the similar things. We're going to be importing the SDK and JSON and our example pops. We're also going to be importing a couple of helper functions from the example pops utility file. We are also going to be importing Pillow and Matplot to visualize the results we're getting out. We're going to use that same photo again. And this time around, we're going to use a slightly more complex pipeline. We're going to use the person 2D pipeline. And so let's take a look at what that looks like. The person 2D pipeline has two components. The first component is, again, looking for any persons in the scene. We're going to give that a category name. This is purely stylistic. This is to allow us to name the results coming back. And you can imagine in some more complex pipelines, this is really helpful for sorting and structuring your results. And then we're going to forward any people we find into a different model. And that model is our EyePop person 2D body points model. That will take any people we found and it will also render and find those 2D body points on that person. Now, for this particular pipeline, we recommend having a confidence threshold of at least 25%. What this will do is it will filter out the lowest confidence body points that are coming back. You can have some pretty wild guesses as you get to lower confidence thresholds. We could also do this in the code in our post-processing. And so it doesn't have to be done here, but I do this for convenience. And so that is what our visualize example is going to run. Again, we're going to upload our image and run predict. We'll dump those JSON results to the screen, but we're also going to do another couple of steps. Number one, this is an optional step. This is if I wanted to filter the objects by confidence, I could do that here. And so I could set this to something greater than 0, between 0 and 1, to filter things by confidence. In the previous example, we saw that person came back with 96% confidence. And so if I wanted to filter lower threshold objects or people out of the scene, I could do that here. Our person detector comes back only with people of high, when it's confident that people are going to be in there. But there are other models like the eyeglasses model that I trained that we're going to take a look at today, and you may want to do some confidence filtering there. Okay, we're going to use Pillow to open the image. We're also going to use matplotlib to plot our results. Our EyePop SDK has a plot function that's a helper to render EyePop results to the screen in Python. Lastly, we are going to look for the biggest person in the scene. And so this utility function walks through each of the objects found, and it's going to just take the one that takes up the most visual real estate in that frame, and it's going to display the key points for that person. All right, so let's run that and see what that looks like. Okay, and so we can see, let's start with the visualization. It found the person in the scene. It's displaying our 2D body points. There are a lot of things we could do to display this differently. It's pretty easy code to render this to the screen. We're just talking X and Y points here. We can have another tutorial about that or workshop later about different ways to render these to a scene. We're using mostly the default EyePop library here to render this box, and then I'm just pasting these at each body point. And so we found pretty good body points here. I like it. Let's look at the code and the JSON that came back. And so we can see this is a much bigger response than we got back before. And the objects that we got back from our pipeline are here. And so we can see we still got back just one object. It's a person, high confidence, and now we're getting key points. And those key points come back it's going to give us a category and then points. And so this comes back as an array. There are some pipelines where you want different types of key points to coexist on the same object. Those are more complex situations. And so we're going to want, we could filter by what category of key points we're interested in this particular um, example. We know from our how we compose this pop, there's only one set of key points that we're going to be looking at today. And so not too worried about doing extra filtering here. We know it's always going to be the first set of key points. These are the key points that it found. You have things like the class label that's going to tell you what key point that is. It's going to tell you confidence. Confidence is important, especially in these key points for key points that the machine can't see. And so it'll make guesses to what it can't see. And that's done for occlusion and just have a complete picture of the person. I found that for those, it's going to guess way lower, and you may want to always filter those out. There are situations where you're looking at a person from the side where it will make some pretty good common sense guesses to where, for example, my left hand is if I'm on the side. But there's also sometimes where it'll guess things pretty wildly, but it will give you a lower confidence there. So this is something you want to definitely check as you're using this in your own code. The X and Y will come back. That is in the coordinates of the image that you provided. And so one of the ways we can we can normalize these coordinates if we want to display this image in a different resolution is by looking the source height and source width. We can normalize all of these coordinates according to the source height and source width. And so that is what we got back. We're also dumping the biggest person found to the console here. And so we can tell the biggest person found was also the only person found here. And so kind of a trivial use case in this particular example, if we have multiple people in the scene, that would potentially be a bigger deal. And so let's try that again. Let's change our image that we're pointed to and take a look at number 2. There we go. And so you can see a slightly different position and picture produces little slightly different results. Great. And so let's start putting this together with some other sorts of logic. And so it's great to visualize it. It's fun, but not super useful. Let's start doing something where we're actually looking for a particular body position in the scene. In this example, number 3, we have all the same setup. We're importing the SDK, we're importing our pops. We're actually using the same exact composed pop, person with 2D body points. We're uploading our image. We can optionally filter by confidence. We're going to be visualizing it. Now, this time around, when we find the biggest person, we're actually going to be looking for something very specific. And so the first thing we're going to do is we'll display those key points again if we found a person at all. And when we find those key points, we're also going to look through each of the key points and we're going to find shoulders and wrists. And what we're looking for is the position where a person has one hand up or the other hand up or both hands up. And the way we do that is by finding these key points. We're going to look for the relative position between the left wrist and the left shoulder and the right wrist and the right shoulder. Then if we find that one of those hands is raised, we are going to be just writing that out to the screen. Okay, here we go. And so in this particular example, this person does not have their hand raised above their shoulder, and we can see those relative points there. And so let's try again with a different example, potentially that example we had just been looking at. And so that was example number 2. And so we can see, yes, definitely both hands are raised, in fact. And so we get our hand raised. We could make this an either or if we're not looking for both hands up, but just one hand up, like I'm asking a question. Certainly we could change the logic pretty easily there. And let's try that again on our first example there. Okay, great. And we also see the relative position here, and we're getting hand raised. So great. Now we're starting to understand body position in that frame. And by the way, if you wanted to pass a video through instead of an image or a live stream, you do the same exact set of steps. That post-processing can be done on each frame. So not only can we know that somebody's raising their hand, we would know at which frame at which frames do they have their hands raised in the video or live stream. In your iPop dashboard, you can go to the My Models tab and you can train your own model based on a collection of images. In this example, I trained a model around the concept of eyeglasses, both people wearing eyeglasses and eyeglasses in direct-to-consumer style ads. And so we can see some examples here. This is the model training area. And you can see in here, this is where we label our images. EyePop.ai makes this really easy with our auto labeler. And you can see on by this dashed box here, that is what it's guessing based on the information we've given it to what I want to label. And we also have confidence thresholds here too. So if I move this all the way down, you can see it's guessing a lot of things. But if I tell it to give me its best guess and put a relatively high confidence threshold on there, then it's going to make my life a lot easier. Now, I could approve this right now. This bounding box looks pretty good. Or I can take a look and see if there's something about it I want to adjust. Now, maybe in my model, I might just be interested in just the eyepieces of glasses. In this particular model, I'm interested in both the eyepieces and the stems. So I want this bounding box tight to every pixel that has glasses on it. And that looks pretty good to me. And so let's save it there. And now that is saved into my model so that when I train on this model, that image is going to be used for training. Some of the things I can look at on the left-hand side are how many images are left to label, the ID of a particular asset. If there is an external name that I uploaded this with, I can have the external name as well. And so we track that in case later I need to use that as a unique identifier back into my collection of images. When I uploaded this particular image and a prioritization. This prioritization is really important, and we order the images based on priority. This is a concept of how dissimilar this image is to other images in my set. We want to be training on very different images that makes a more robust model. We also want to understand where either our previous iteration of a model or the auto labeler are uncertain. That's going to give us really good data around great great images to train on. And so in this particular model, that I'm building, we're on version 10. And so the auto labeler in this particular one is using the previous version of our model. If I'm starting from scratch, we have a foundational technology that auto labels pretty much everything that you can find on the web. And that would be used for the first pass. And so when I'm done training, or excuse me, when I'm done labeling my images, I will go to training. This will give me a sense of how ready I am to train this model. It talks about how many labels are there, how many negative examples I have. Negative examples are very important for models. That is instances of images without my particular object in them trained into there. And so, for example, in this one, when I take my glasses off, the first version of this model that had no negative examples would also put a bounding box around my eyes with fairly high confidence because all the people I showed the model in my data set all had glasses. And so it was starting to get the eye region confused with the glasses itself. When I added negative examples, people without glasses, and put no bounding boxes in those and approved those images into my data set, that disambiguated the eyes from the glasses, and the model got a lot smarter about what it guesses. Now here, it looks like I'm pretty good to go here. I've worked on a couple iterations of this model to get it ready to train. But if I'm not ready or I just want to add more data is generally better. I can go back, upload more images, go back and review my labels for consistency and making sure that I've labeled enough, and then I would hit start training. Now I will skip ahead to a model that we've already trained. And so I'm going to go back to my models area. In my models, I can take a look at models I've already trained. And so those appear at the top. And I'm going to go ahead and deploy this model. Now, we have two modalities where you can deploy models. You can deploy them to our cloud. You can also deploy them to the edge. The model page is going to give me some information about my model. So we're on version 10 here. I can go back and look at other versions of my model. I can also look at the current stats from my model. This is one way of looking at how the performance of a particular model. It's the precision, versus recall curve over confidence. We call that CPR curve. And what I want to see here is this curve to take up as much visual real estate on this one by one box as it can. And so this is pretty good. This means that it's training fairly well for my data set. On the cloud, if I want to compose a pop, I can compose that pop just like we did in the Python example using code, or I can do it through the UI. And so I could potentially deploy this with person and 2D body points, deploy it to the cloud and start to ping it for inference. In today's example, we're going to be deploying to the edge, and we're going to be using the Qualcomm AI Hub to optimize our model before it's deployed. So I'm going to click over to edge. Now I've already optimized this model, but let's go back through it again, and I can show you what that looks like. I've already entered my API key in here. The first time through, it'll ask you for your Qualcomm AI Hub API key, and so you'd enter that in, and then you would select a device. Now on our devices here, I'm going to go and I'm going to select in before, and this is what we're using today, is the Snapdragon X Elite CRD. Let's select one of the other Snapdragon X devices just to show you how that would look. And so what this is doing is it's taking that device, it's going to upload it to the Qualcomm AI Hub, and we're targeting a specific device deployment. This is going to configure that model export specifically to run better on the targeted device. This generally takes about a minute. And then it is ready to go and to use both on your Qualcomm AI Hub as well as your EyePop runtime. Okay, and we're there. And so now I have a model UUID that references all of the exports that I may need in my runtime. The runtime plus the UUID will determine what model is pulled down from EyePop. I'm going to take this model UUID and let's check back in on our Python code. Okay, here we go. Okay, great. And so for our last Python example, we're going to be using our custom exported optimized model along with person with 2D body points and get all of that data back together. Now, let's take a look at first how I would compose that as a pop. And so the one different thing we're doing in this one is composing that eyeglass model in there. In our composable pop syntax, I could use this model by itself, and that's what this one represents. Very similar to how I talked about a model in for EyePop standard models. In this one, I'm going to talk about a model UUID, and that's going to reference the model that we just exported. I can also compose this in a pipeline. And so here is a pipeline of model plus finding people. You can see these are side-by-side components here. So it's going to look for use both models on the full image to look for both objects, people and eyeglasses. And then lastly, here's the pipeline we're going to be using. To do this, it's going to use side by side our new model, eyeglasses, and people. And then it's going to forward the people it's detected into the 2D body points model pipeline. Okay. All right. And that's the main difference here. Everything else is roughly the same. So let's go and actually run this on our PowerShell. Okay, here I am in my Windows PowerShell. We're going to run our last example in Python, which is our custom model. Now, you'll notice it's taking a little bit more time than usual, and that was just to pull down that custom model for the first time. And here we see we have our person with their hand raised. We're not visualizing the key points in this particular example, so that is why we're not seeing them there. We are getting those key points back. We didn't get any eyeglasses back, which is expected. That image didn't have any. So good news there. Now let's go back to our code. Let's change this to one of our images that does have eyeglasses, example 3 and example 5. And then there are sunglasses in example 2. So there's a lot of things we can try out here. Let's check example 5. And we will run that. Okay, great. So this is good expected results. And let's take a look at the actual output here that gave us this. And so when we look at our output for example 5, we can see it found one eyeglass object and it found one person object. So that's to be expected. The eyeglasses came through with high confidence, so that's great. We would expect to see that. For custom models that you trained, especially in the first couple versions of the iteration on training those models, you may find that there are some lower confidence guesses. And so if we go back over to the code here, you can see in this example, I am actually um, separating the things we are visualizing by confidence threshold. And so I found that my eyeglasses model works very well at 85% confidence threshold. Below that, it may make some guesses that are not eyeglasses. And so we filter those out and, no worries there. Let's take a look at one more example here for, I believe it's example 2. Okay, and so here I did not give my eyeglass model any sunglasses. That is a separate object that, as I build out that model, I actually want to have as a different class in my model, a different label. And so let's look at the JSON coming back. And so we can see it actually found two eyeglasses. They're right around where the sunglasses are, but we can see they came back with lower confidence thresholds. And so if we wanted to find objects like our target object, we may want to use lower confidence threshold um, for that. I specifically chose 0.85 from experimental data because I do want to filter out anything that's not eyeglasses specifically. And what I could do in my model, if I wanted to get much more rigorous about this, is I could also give my model a ton of negative examples of people wearing sunglasses and explicitly telling the model in that training step that these sunglass people images are not eyeglasses, and so don't count those. Um, so that is how I can pull down a custom model, use it, and I also can compose it with a different pipeline. That is the extent of our Python examples today. Now I'm going to switch over to React. Our React shell is also in our demos. And so if you want to run this Python code, it's in our public demos in the Python directory in Windows Runtime Edge deployment. All the things I showed here today are in there. Same thing with everything I'm going to show today in our React shell. It's in React, IPOP React shell. And the core functionality we're going to be looking at today is all in person pose upload local. And so let's take a look at that. The way our React shell works is it runs in three modes. Image mode, and you can take an image from a webcam or you can upload an image in there. It runs in video mode, and in that one, it's about uploading batch video that I have on my device into the iPop shell and running inference on that. And lastly, live mode. That's taking the webcam or sharing a screen on the device I'm working on to run each frame through inference and IPOP using WebRTC and WebSocket technology. Now, today's example is going to be about uploading images and taking images that we're going to upload and run through our local runtime. But you can also do this in live mode or video mode just as easily as photo mode. Now, React is a slightly different SDK, and you can ignore some of these warnings I'm getting from my IDE. But what you'll do is you'll import our SDK. Our SDK comes down as at ipop/ipop. We also have a render SDK, and so separately from the Python SDK that encapsulates simple rendering, we have much more complex rendering that you can do with our React render SDK. And so if you want to use our out-of-the-box rendering, you can do that. You can also very simply draw some of these things yourself using Canvas or other technologies that allow you to draw to the screen. For setting up our endpoint on React, these processors that I have set up are all just mini examples, and they'll use some combination of taking a photo, uploading a video, or connecting into a live stream. And it just depends on which example you're looking at, what it's best at. In today's example, we're going to be setting up our endpoint connection. That's going to be a connection that is there for uploading things into. So we're not going to connect the stream today in this example. Um, but if you look in our examples, there's plenty of examples of how to connect in a stream, including person pose live that is made for connecting into the local stream. So we're going to connect our endpoint, and then we're going to pass a photo into it, just like we did in Python. And in React, we start with same sort of concept. We want to set up a worker endpoint. In React, we are going to await our worker endpoint instantiation, and we're going to use is local mode true. This is a little bit different than the Python setup. In the Python setup, we actually did the same thing. We just did it in the environment variables. And in that README, you can read about how to set up your environment variables in PowerShell or the command prompt. But here we're just going to pass it in explicitly, and we're also going to connect to that endpoint. That connection we're going to store as a state variable on this processor called endpoint, and that's going to be the place that we do a lot more processing on. Just like the Python example, we're also going to compose our POP. And so there's really two modes you can use iPop in. Often from the cloud, we find customers, it's easier for them to compose a pipeline on the dashboard UI. That gives you a POP UUID that you can pass into your endpoint, and your endpoint is just a pre-configured pipeline. If you want to change your pipeline on the fly or do something a little bit more customized, then you can use change pop just like we had on the Python side. In this one, also just like Python side, we have a library of composable pops. In today's example particularly, we're going to look at the same sort of person and 2D pipeline. The syntax is slightly different in the JavaScript version versus the Python, but all the same elements are there. We're going to be typing this as an inference component. We're going to be using the iPop person latest model to find people in a scene. We're going to be forwarding that those people into our key point detection for iPop person 2D body points and getting the JSON output from that. And so let's look at that together. And so let me go back to person pose upload. So we're going to change our endpoint to that. That happens, this set canvas context happens when our example is loaded, and we'll see a little spinny circle until that is done. And that's all handled by this page TSX that handles the UI and the coordination with the different places. That stays the same for all of these examples. So we can take a look at the code there as we get deeper into what it's doing, but there's not a lot of interesting things happening there. Mostly just UX stuff. We're also going to be setting up a renderer. Now, in today's renderer, we're going to render pose and we're going to render boxes. And so we have a lot more control over how we're rendering things. There are other pipelines that actually form contours or outlines around a particular detected object. If you notice, we had SAM2 as a pipeline within this. You can also compose SAM2 with some other models. So you can compose SAM2 with your own model. You could compose it with person, and you can see how that looks like that. And so instead of getting boxes in that example, we're getting contours. So there is a render contours class or function that helps you render those polygons instead of boxes. Today, we're going to be looking at render pose, render box. And the last thing we're going to look at here is, okay, how do we actually do the upload? So process photo is called anytime the user has the intent of sending in either a local file or a picture that they took with their webcam. That passes that into this function. For this function, we are doing something similar to the Python, but it's slightly different syntax where we're calling process. Process does both the upload and the prediction. It's combined because this takes in some more complicated parameters. You also can use, instead of files, a URL that's publicly accessible on the web. You can pass in a blob. You can pass in lots of different types of media into this. You can also change this code to pass in a video just by changing the MIME type and what file this is pointed to. We are going to await the results coming back from here, and this is what is going to give us each of those JSON results. Now, this canvas code, this is optional. This is just a UX decision to change our canvas that we're visualizing these things on to the same resolution space as the thing we uploaded in the first place. And then we call this renderer draw. That is what allows us to draw to the screen. We don't need to do anything else. We've really simplified the logic here. And this is configured, of course, by how we instantiated the renderer in the first place. And so let's take a look at that working, and then we can go deeper on some of the pieces there. So we have our runtime running. We have our example app running here. And I'm going to just refresh it because I've been doing some work on this. I'm going to move my other device so that I'm fully in frame. And here I am on the webcam. And I can tell immediately I'm on a different demo. And so I'm going to switch over to our Edge runtime upload detect person pose. That you saw that little spin, that is connecting up to your endpoint and making sure it's ready to do work. And then I'm going to look over here and take a picture. And so you can tell that happened very instantaneously. It's always surprising me how fast this happens on the edge because there's no latency. It is passing that information directly into your local runtime. We're going to take a look at what the processing here in a second on the NPU, but we can tell that this found a person. We opted to turn the labels off. So you're just going to see the box and you're going to see these little points at our key points in the scene. And so just like in Python, we could use these key points to do work in a post-processing scenario. I'm going to reset this here. I'm now going to bring up let's bring up the performance monitor. So I'm going to bring up Task Manager. I'm going to switch over to the performance monitor. And one of the things we're going to look at is the NPU. And so we can see the NPU is not doing too much right now. There's not a lot for it to do. But if I hit this button, okay, and that sent an image up there to do work. Let's take a look at that. And so we saw a slight blip when it was doing inference on the machine. Now, if you pass in a video, you'll see this spike up a little bit more, but that is the NPU actually doing the processing on the device. So very exciting to see it running locally there. And let me refresh that. Okay, great. So let's dive in just to explain what's happening on the page. Lots of different examples in this demo repo. And so you can take a look there. Start camera is that thing that's giving us the camera preview initially. That also for the right examples. And if we jump into person live, that's setting the stream. That stream is using the endpoint in a different way. It's using the endpoint to create a live ingress. And this is creating a local streaming WebRTC to your runtime. And so everything coming into that camera preview is being streamed out to your runtime. Then we have to configure the runtime to process that live stream. And so that is how this piece of code here is how that happens. We still do the for await, but instead of using that prediction right away, this will buffer the last result into the last prediction. And then there's lots of things that we can do from there. If we go back to page, every frame that we have for request to animation frame, there's a little bit of work being done. We're drawing to the canvas. There are other examples that require a region of interest. We're not going to be talking about that today, but that'll be for a future workshop, especially around SAM2 and how to operationalize that. We are going to be drawing the current camera preview to the canvas, and so that's how we're visualizing that there. And we're sending a signal to process frame. And so for our live examples, any post-processing that we wanted to do would be done in our process frame inside of the processor. This is how we're sending our process photo up to our processor. And so anytime we either take a picture or upload a picture, it's going to send it in there. And so we can take a look at that example. We're going to, instead of using the webcam on the device, we're going to be using a file that we're uploading into our runtime. And so let's use one of our examples from our Python. And we can see here that came back right away with the person detected in the scene, also the key points detected on their body. And so we can do a lot more with this visualization if we wanted to. You can configure this to change the colors, change size. You can write your own custom renderer around these key points. You really have a lot of freedom there. So that's it for the workshop today. I hope you all had fun taking a look at what we can do at the edge, especially using our Snapdragon X Elite device and the Qualcomm AI Hub. And so if you have any questions, let me know. We're always around. Please visit our Discord and talk to us there. You can also talk to us directly at hello@eyepop.ai. But thanks a lot for listening and talk to you soon.